So a smooth circular cylinder of radius 1.5 meter is laying in a triangular groove, one side of which makes 15 degrees angle and the other 40 degrees with the horizontal. Find the reactions at the surface of contact if there is no friction and the cylinder weighs 1 kilonewton. Here smooth circular cylinder. So cylinder cross section of the cylinder is circular section and it is laying in a triangular groove. So that triangular groove, the one side of triangular groove makes 15 degrees angle and the other 40 degrees with the horizontal. So here we are going to draw. So one side of the triangular groove is making 15 degrees angle with the horizontal. So here we are drawing a horizontal line, and one side of triangular groove is making an angle 15 degrees, and the other side of the triangular groove is making 40 degrees the horizontal. And the thing, it is making an angle 40 degrees. So this is a triangular groove. So actually the triangular groove, it will be like this. So in this we are going to place a circular cylinder, circular cross section of cylinder we are going to place in this triangular groove. So here we are drawing only the front view. Whenever you see in front view, the cross section of the cylinder is circular. So here we are going to draw only circular cross section of that cylinder. Okay. So here we are placing a circular cylinder, and here we are drawing only the front view portion. So we place a circular cylinder in a triangular groove, and here we want to find the reactions at the surface of contact. So find the reactions. So reactions means here, for example, if you apply any force on your body, according to Newton's third law, for every force there will be a reaction force developed in that body. So here also, so whenever you place a cylinder in this triangular groove, so wherever it is going to make contact, so at that contact point a reaction force will be developed. So that reaction force will be given by triangular groove. So here the surface of contact is, so here we place a circular cylinder and it is making a point of contact is here, and it is making a point of contact with this triangular groove here. So this is the surface contact and this is the surface contact. These are the 2 points. So at these 2 points some reaction forces will be developed. So those reaction forces, here we are assuming this point of contact or surface contact is here, we are seeing some A, and this point here we are assuming B. So whenever this circular cylinder is going to make a point of contact with this triangular groove, so some reaction force will be developed, because this circular cylinder has some weight. Weight means force. So some force it is applying on this triangular groove. So a circular cylinder is applying some force on this triangular groove wherever it is going to make a contact. So this triangular groove also will give some reaction force according to Newton's third law. So that reaction force here we are assuming RA. So we have to find out these reaction forces. and here also, and this reaction force is always perpendicular to the surface. So that's why this is the triangular groove surface. So we are drawing right angle perpendicular to the to that surface, and here also a reaction force. This reaction force here we are assuming RB. So RA and RB, these are the two reaction forces at the point of contact, at the surface contact between triangular groove and circular cylinder. So these are the two reaction forces. We have to find out this RA and RB, and if there is no friction, so here we are not considering any frictional forces. So we are neglecting frictional forces, that's why we are not going to show any frictional forces in this diagram. So only these two forces, two reaction forces RA and RB, and the cylinder weighs 1 kilonewton. So weight is 1 kilonewton. So here weight always acts in downward direction. So here the weight is 1 force, so that weight is 1 kilonewton. So that means 1000 Newton. Weight is 1000 Newton. So these are the three forces acting on circular cylinder. So RA and RB reaction forces and weight 1000 Newton. So here we already know the weight. We have to find out this RA and RB. So for that we have to draw free body diagram. So free body diagram means we have to remove all the supports and all the elements, and we have to show only forces and then directions. And here we are assuming this circular cylinder be placed the circular cylinder we placed on a triangular groove. So now the circular cylinder is in rest condition. So even though different forces are acting, the body is in rest condition. So here reaction force RB is acting, RA is acting, and 1000 Newton weight is acting. So the three forces are acting, but the body is in stationary condition or in rest position. That means there is no movement present in the body. So whenever different number of forces are acting on the body, so even though different forces are acting on the body, if that body is in rest condition or stationary condition, then we can say this body is in equilibrium. So now the body is in equilibrium. So here we are assuming the body is in equilibrium. So when the cylinder is in equilibrium under the action of W, RA and RB, so we can apply Lamis theorem at that in that equilibrium condition. So first we have to draw free body diagram. So for that, so here we are drawing W, thousand Newton, so here RA, RB and 1000 Newton. So whenever this body is in equilibrium condition, so all these three forces are meeting at one point. So all these three forces are meeting at one point. So here what we are doing, we are extending this reaction force RB line. So this is we are going to show So this one is RB and this is RA. For our easy calculation, here what we are doing is we are extending this RB up to here, and also we are extending RA like this. So whenever you extend, so finally the free body diagram will be look like this. So RA, so you are extending the line RA through this point, center point, so RA, and this is RB, extending the line RB, and the weight W 1000 Newton, it is W 1000 Newton. So if we get this type of format, then it is easy to calculate using Lamis theorem. So that's why we extended these lines. So RA, RB and 1000. Now the body is now in equilibrium condition. So we can apply Lamis theorem. So here we have to find out the angle between RA and RB, and RA and 1000 Newton, and RB and 1000 Newton. So for that, from figure we have 40 degrees and 15 degrees. So these triangular grooves, one side of the triangular groove making 15 degrees with the horizontal, here it is making 40 degrees. So here we are separately drawing. So here it is 40 degrees, and this line is RB, reaction force. So this here a triangle is forming. This reaction force is perpendicular to the surface of contact, so 90 degrees. So 40 and this is 90. This is a triangle. A small triangle is forming here. So a small triangle, here we are separately drawing. So this is 40 and this is 90. So the remaining angle is, here it is 50 degrees. So here RB is, it is making an angle, the horizontal is 50 degrees. So here from this triangle, from this big triangle, you can see this angle is 50 degrees. So if this is 50, so this is the triangle. From this triangle, this is 50, so this is 90, so this angle will become 40 degrees. So here this angle is 40 degrees. So from this red color triangle, from this big triangle, so we calculated this angle is 50 degrees. This is 50 and this is 90. So automatically it will become 40 degrees. So whatever the 40 degrees angle, this side of the triangle making the horizontal, the same 40 degrees will come here also. So this side also, if it is 15 degrees, so this angle will also become 15 degrees. So here this is 40 degrees, this is 15 degrees. So if you draw a horizontal line here and draw a vertical line for calculations. Vertical line and horizontal line. So now we have an angle between RB and RA. So RB and RA, the angle between RB and RA is 40 plus 15. So here the angle between RB and RA is 40 plus 15, 55 degrees. So the angle between RA and RB is here. So after extending also the angle doesn't change. So the angle between RB and RA is 55 degrees. So here we are directly writing 55 degrees. So 40 plus 50, 55 degrees. So or you can write same as, so if this is 40, because we have to calculate the angle between RA and 1000 Newton and RB and 1000 Newton also. So for that here what we are doing means, here this angle is 40 degrees, RB and W is 40 degrees in this case. So if this is 40 degrees, this will become 40 degrees. If this is 15 degrees, this will also become 15 degrees. So same as here also I am writing. So this is 15 degrees. So this angle is 40 degrees. So total angle is 55 degrees. So here we are separately writing. So the angle between this vertical line and RA is 15 degrees. And this vertical line and RB is 40 degrees. So 15, 40, total 55 degrees. So now the angle between RA and 1000 Newton is, so this is a vertical line. That means total 180 degrees. So already 15 degrees is over. So remaining angle is 180 minus 15. Here also total this angle is 180 degrees. So already 40 degrees is completed. So the remaining angle between RB and 1000 Newton is 180 minus 40 degrees. So now we can apply Lamis theorem. So from Lamis theorem, so 1000 by sine of angle between other two forces. Sine of angle between other two forces RA and RB. The angle between RA and RB is 40 plus 15, total 55 degrees. So sine 55 degrees. Next, if you consider RA by sine of angle between other two forces RB and 1000 Newton. The angle between RA and RB is 180 minus 40. Sine of 180 minus 40. Next RB by sine of angle between other two forces 180 1000 and RA. The angle between them is 180 minus 15. RB by sine of 180 minus 15. So from this equation you can calculate the unknown reaction forces RA and RB. So RA will be equal to 1000 into sine 180 minus 40 sine 140 by sine 55 degrees. So RB equal to 1000 into sine 180 minus 15 equal to 165. So sine 165 degrees sin 55 degrees. So if you calculate, then you will get some 784.7 Newton. Here you will get some 315.9 Newton. So these are the unknown reaction forces whenever you place a cylinder on a triangular groove.